Hello everyone. Today we're going to start looking at the Algebra of Quadratics, which is actually going to be a little bit of a review of some of the concepts in grade 10. One of these methods is actually used more often in grade 10 than the other, but quadratics algebra actually repeats itself in grade 10, 11, and 12, and it's just to show how important quadratics can be depending on which program you end up in post-secondary school. So there are two main ways of doing the algebra of quadratics. One of them is by using transformations, and the other one is by using the zeros or the roots of an equation. Now I'm going to write the general equations of both of these methods. They're going to look rather confusing, especially the first one, but we will be breaking it down into small little pieces as we go through, so don't worry about it too much right now. So we have y is equal to a times x minus h squared plus k for the transformation method, and we have y is equal to a times x minus s, and I'm using this fancy s so it doesn't look like a 5, times x minus t. So those are the two general equations for quadratics and algebra. Okay, so we're actually going to start with the transformations one, and like I said, we're going to break it down slowly into pieces. We're going to start by looking at what does this k value do to the equation, and what does this a value do to the equation, and then we'll look at what the h value looks at. We're not doing all of that today. We're going to be looking at k, and we might start looking at a today. And then we'll come back and do the second section of the quadratics unit, and we'll look at the zeros method of looking at quadratics in algebra. Okay? So what I'd like actually to do at this point is to switch over to the Desmos program. So what I'd like to do first is I'd like to create I'd actually like to write so we talked about the general forms of the equations, but I want to talk about the most basic form of a quadratic equation, which is y is equal to x to the power of 2. Okay, so I typed in y is equal to x to the power of 2. Now if you're trying this at home, there's a keyboard on your phones that you can call up, and the power of 2 button is right here. Or if you're on a keyboard on your computer, Shift 6 gives you the power button on a keyboard, and that's what I used, although I was missing it a little bit there. Yeah, so Shift 6 or this little button here will give you a power of 2. Okay? So this is a parabola. You've seen this in grade 10, right? But what I'd like to do is start linking the parabola to the table of values to the equation. Okay, so the equation and the graph are exactly the same thing, just two different representations of exactly the same thing. So is the table of values. All three of these things are linked together. Okay, and the faster you can start linking the equation to the graph in your head and the table of values to the equation and to the graph in your head, the better you'll understand math in general. All right, so I really want to spend a little bit of time explaining, and I may have done this before, but I want to do it again. How is y equals x squared generating this graph? Okay, so what we're going to do is we're going to do a table of values, and I'm going to put in just a few little x values here. So we're going to put in -3, -2, and now Desmos knows that I want to go up by 1s all the way up to 3. Okay, so I'm using -3 to 3 as my starting x values. You are free to use whatever x values you want. When you're free to use whatever x values you want, it's good to use a smattering of every kind of x value. So every kind of number. So a negative number, 0, and a positive number. Now we're going to generate the y values. Now I said generate. these you can't just pick on your own, because y is controlled by this equation. Y is given by whatever x is squared. So in other words, the heights of the parabola, like where these points are controlled by that equation. Okay, they're not just randomly generated, and that's why there's a pattern. So, and I'm actually going to zoom in a little bit on this. I just want to go up by ones here so we see all of the different values. So you can see that this graph goes from, it goes from beyond -3, but I definitely have an x equals -3 all the way up to 3, right? And I definitely have all of the y values going 1, 2, 3, 4, 5, right? So here's my -3x value. I need to generate the y value with the equation. So I'm going to substitute -3 in for x. What is -3 squared? Now you've got to be very careful when you type this into a calculator. Some calculators I'll actually do this wrong, but most calculators have a negative button, not a minus button, a negative button, okay? So I actually recommend my students always put these numbers in brackets. So they would do bracket -3 bracket squared, just to make sure everything works properly. But when you do that, and you can probably do it in your head, what's -3 squared mean? It means -3 times -3. Well, -3 times -3 is 9. What's -2 times -2, which is -2 squared? So we're taking this new x value, and we're finding out what is the corresponding y value by substituting it into the equation to generate that y value. Well, -2 times -2 is 4. What's -1 squared? -1 times -1 is +1. What's 0 squared? Now you're starting to see something appearing on the graph, and those are the dots from the table of values. You can tell because they're colored purple, like the table of values, y value is saying, right? And they're following the graph perfectly. So what is 0 squared? 0 squared is 0. What is 1 squared? It's 1. Sorry about that. What is 2 squared? It's 4. And what is 3 squared? It's 9. Now, why are we not seeing the 9s? We're not seeing the 9s because they're way up here. Okay, but you can see that those are on the parabola as well. So if we look at the graph now and look at the idea of the table, okay? We started at -3, we squared it, and we went all the way to 9 and put a dot there. We went to -2 and squared it, and went up to 4 and put a dot there. -1 squared, put a 1, 0 squared, on and on this side, and we get this perfectly parabolic shape when we do that. So the equation y equals x squared generated the points to create this graph. Therefore, the graph and the equation are the same thing. The equation also generated the table of values. So the table of values and the equation are the same thing, and that means that the table of values and the graph are the same thing. So all these three things are representations of the same thing. And there's actually a fourth one, which is word problems. Okay, so there's actually 4 different ways of representing a quadratic scenario: a word problem, a graph, an equation, and a table of values. Now there's some very interesting characteristics about these points. And if you remember, we talked about first and second differences. Now, I don't think I can do first and second differences on Desmos, but if we do our first differences, okay, I'm just going to show you orally. What's 9 minus 4, 4 minus 1, etc., etc. Well, let's start with 9 minus 4. Okay, well, what is 9 minus 4? 9 is the height of this point, right here. 4 is the height of this point, right here. What is the difference in their heights? The difference in their heights is 5. What is the next first difference? 4 minus 1. Well, 4 height is here. 1 height is here. What's the difference in their heights? The difference in their heights is 3. 1, 2, 3. So your first differences tell you the difference in the heights between each point. By the way, it's the same difference over here, except it's negative, because we read the graph from left to right this way. This would be the point, and what we would be talking about here is like 1 and 4 right here on the table, okay? The difference in the heights between these 2 points is -3, because we're going down to get from the 4 to the 1 height on this side of the parabola, so the difference in height is -3, whereas we're going up to get from the difference, and remember we're reading points left to right, so this point to this point, we read left to right, and the difference in height is 3. So that's where the first differences come into play. Well, what about the second differences? So 9 minus 4 was 5, 4 minus 1 was 3. What's the difference between 5 and 3? The difference is 2. Well, where does that 2 second difference appear on the parabola? Now that's a little bit harder to see, but the first height was 1, the second height was 4, it was 3, the difference in heights was 3. If this height is 1 and this difference in height is 3, what's the difference in the difference in heights? 1 and 3 are different by 2. The next difference in heights is 3 and 5. What's the difference in the difference in heights? It's 2. Now that part you don't need to understand as well. Some of you may have gotten the pattern from the table, but that's where it all appears on the graph. So everything is related. Everything is related. Okay? Now what I want to talk about is what happens to the graph if I add 2 to the equation. Now with Desmos, I can show you that very, very easily. So actually I'm going to add 3 so that it doesn't get you confused with the power of 2 in the x, okay? So let's do y is equal to x squared. And now I'm going to add a number to that, okay? So at the very end of the equation, I'm going to add a +3. Where's my plus on my keyboard? You know what? I might just pull up the keyboard here and use the plus right there, 3. Okay, now I want to change the color of that. I know there's a way of doing it, but I'm not sure how. Anyway, so what did we just do to the parabola? I'm hoping everybody can see that the parabola just moved up by 3. Okay, it started at, if we talk about the starting point as the vertex, which is often the easiest point to see, the graph moved up by 3 here. So the new vertex is at 0, 3. Now, what is the relationship between this and what I was talking about earlier about the different ways of representing parabolas? I'm going to transition back to my smartboard here. This plus k is that +3. Okay, so by changing the k value, I'm trying to explain what happens to the graph. All right, just so you could see what was going on there. So when I add 3 to the parabola, it moves the entire parabola up by 3. Okay, well, what does that do to the table of values? So let's do another table of values. Okay, we're going to do -3, -2, -1, 0, 1, 2, 3 again. And let's add 3. So what am I saying to do here? I'm saying take the y value, which is x squared, which generated 9410149, and add 3 to all of those y values. So it's going to be 9 plus 3, which is 11, 4 plus 3, which is 7, 1 plus 3, which is 4, 0 plus 3, which is 0, and you can see those points appearing on the parabola, the second parabola now. At 1, it's 1, so 1 plus 3 is 4. At the next one is 4 plus 3 is 7, and the next one is 9 plus 3, which is 11. So this equation just means take the original table, which is the x squared table, take all the y values, and just add 3 to them. and then you get your new parabola. So the idea here is, can you understand that all we're doing is taking the heights and adding 3? So the height of 1 goes up by 3. The height of 0 goes up by 3, etc., etc. And where I'm heading with this is I really need students to be able to do this in their head and quickly sketch the new parabola. And you're going to have to do it without technology sometimes. So what is the most efficient way of doing that? Well, the most efficient way of doing that is to know what is the original table of values, and then just add 3 to all of the y values. Now, knowing that, I'm going to actually get rid of the table here. What would happen if I change this to a -3 instead? Well, let's think of this logically. If I take all of the y values and follow the same idea as before, instead of adding 3, I subtract 3 from all the y values. So I have a height of 1, and I subtract 3 from it. Well, subtracting 3 from 1 gives -2. I'd be going down by 3. If I have 0 and I subtract 3, I'm going down by 3. So let's see what happens to our parabola. I'm going to subtract 3, and sure enough, the parabola has moved down by 3. Now I want you to, I'm going to zoom out here a little bit and show you something. Nothing else on the parabola has changed. It's a little bit difficult to see, and maybe if I take off this one here, it might be a little bit easier. If I take this first parabola and just, put a pencil, I can't do this on digital, unfortunately, but if I just put a pencil mark around that parabola and then moved it down, actually I might be able to show you in another way. Just give me a second. I'm just going to copy and paste this into the smartboard. So let me transition over to my smartboard here. Okay, so I'm going to label these two parabolas here, so this will be in your note as well. So this parabola here is y is equal to x squared. This parabola here is y is equal to x squared minus 3. And what I want to do is I want to show you, and I'm going to try to follow along this parabola. Oh, this is really hard to do. Maybe I won't be able to do this. I'll do it in segments like this. Okay, so if I select the graph and move it up, can you see how the second parabola is the exact same shape as the first parabola? I haven't changed the shape at all. I've just moved it down by 3. Okay? So, so we now know what this k-value does, right? This k-value is just this whole complicated equation, getting rid of the a and the h because we're not using those transformations right now. We're just doing the transformation of k, and we're moving the parabola up or down. Okay, so I'm going to write a little bit of a note here to explain all of that. So we're going to start with y is equal to x squared plus k. So all we're doing is focusing on that one transformation, all right? And what we've discovered is if k is a positive number, the parabola moves up. Now, in math, there's actually a name for sliding things up and down and left and right. And that name, you may have heard before, is a translation. And when we're moving things upwards or downwards, we call those vertical translations. So it's a positive vertical translation or a vertical translation up. So what happens if k is negative? So if k is a negative number, the parabola moves down, which is again a vertical translation. Now, I'll often truncate the words vertical translation to just that, just so that we don't have to write the whole word, a vertical translation down. So that is your first introduction to, and you might have seen a little bit of this last year depending on what your teacher showed you, to what the transformations of parabolas is all about. If we know the original x squared equation, and then we just give you a plus k, then you can graph any parabola. So what kind of work could I ask you to do with this? So what I could ask you to do is sketch y is equal to x squared minus 4. Okay. Now immediately what I'm hoping is happening in your head is you are visualizing a parabola that is sliding down on the graph by 4. Okay? But this is what you'd have to do. Actually, let me do that a little bit nicer, sorry. This is what you'd actually have to do by hand. So you'd have to start with a table of values. Now we're going to speed things up just a little bit. Instead of going from -3 to 3, we're just going to go from -2 to 2. Okay? Because once you know how this pattern works, you don't technically need to go all the way to -3, and it only gives us 5 points to deal with instead of 7. Okay? So what is the regular parabola? Well, I'm hoping that you will eventually have memorized this. All right? You're just squaring all the values, so it's 4, 1, 0, 1, 4. And if you went to -3, it'd be 9, 4, 1, 0, 1, 4, 9. Okay? But 4, 1, 0, 1, 4 is usually more than enough to memorize to do this. And then you're going to create a new table using this transformation and remembering that that transformation affects the y values. So we're subtracting 4 from all the y values. So we're going to go -4, -4, -4, all the way down. And then we're going to create another table of values with those new numbers. So we've got our new x and y, and our new x and y is going to be -2, -1, 0, 1, 2. Those x values don't change, but our y values are going to be 0, -3, -4, -3, and 0. And what you can then do really quickly, now we're doing this really quick because we don't have graph paper. If you did have graph paper, I'd want you to plot those points on the graph paper following the proper conventions, okay? But just to show you, at -2x and 0y, so what does that mean? So remember that x-axis values are here, y-axis values are here, okay? So you always go x first and then y. So x is -2, well -2 is here, and 0. So I'm going to have a point there. Then -1 and -3. Well, -3 would be like down here for your y value, and you're going to put a point there. And then 0 and -4, which is about there. You're going to put a point there. And then 1 and -3 is, now we're going to talk about this fact that they're exactly the same height on either side of the y-axis here. And then I know that these are going to be exactly the same distance away on the y-axis as well. Now, we talked about a special point called the Axis of Symmetry. The axis, well, sorry about that. Let's try to get a straight line across that. So I'm going to use this green one here. So this line right here, yes, it's the y-axis, but it's also called the axis of symmetry because the points are symmetrical on either side. If you put a mirror along that line, those points would be exactly the same distance away from the mirror on each side. Okay, so that is your axis of symmetry. And I'm going to try this, folks. It's really hard to do. I'm going to try to draw a parabola through all those points. That's about as good as I can get it. It's a little bit easier on paper. Okay, so there's your parabola. And remember, we moved it down by 4 with our k value. So just to recap all of that, you start with your x's and y's of your regular y is equal to x squared equation, and then you take whatever your k value is and you add it, or subtract it in this case, to your y values, and you generate a new table of values that you can then plot to graph the parabola. And that's going to be the majority of the work. So if k is negative, it moves down, and if k is positive, it moves up. And I think, even though I said I might touch on A today, I'm going to change my mind and just stop there for today. That's already long enough for this lesson. Expect some homework questions about this, and have a great day, everyone.